Welcome back for another video. In this video, we're going to be going over Lathe tutorial number 2, C&Y Axis. This is the handout that you will find on the portal. It'll be this part right here. So if you go to the portal under Lathe C&Y Axis tutorial 2, this should be attached. All right, so let's get started with this. First thing we're going to do, before we start drawing, we're going to set up our environment here. So I am going to start by selecting a machine. For this machine, I'm going to select default. You have to select default for this one because this requires a subspindle. So if you do not have a subspindle in the post you usually use, which this Has4 axis does not, we have to go ahead and use default because that will give us access to basically everything. So I'm going to select default for this. I'm going to go to my planes, going to work off my DZ plane, and we're going to be toggling back and forth between the DZ and the top plane because we need to do quite a bit of live tooling geometry. So we have to put some of these lines in, and we'll be working on the right plane, all kind of stuff. So this will be a little different from traditional. All right, so let's start with the profile first. So, by the way, when I start this, I'm going to take a look at this here ellipse, and I'm going to turn that. It looks like I have 2 inches is the maximum diameter of that ellipse. So I'm just going to make a step at 2 inches. I'm actually going to make it a little bit bigger so that it cleans up. So let's go ahead and start our wireframe endpoints, and we're going to do multi-line 0, 0, enter. And I'm going to go to 2.0, 0. Actually, check that. We're going to go a little bigger than that. Let me scratch that. 0, 0, enter. 2.01, 0, enter. 2.01, negative 0.15, enter. And then we're going up to 2.35, negative 0.15, enter. 2.35, negative 0.9, and then we're putting that angle in. So we're going to, looks like a diameter of 1.25, 1.25, negative 1.45, 1.25, negative, what is that, 2.95. 2.95, enter. And then we're going back up to 2.35, negative 3.5, enter. 2.35, negative 4.25. And so for that shape, that kind of lobed shape on the back side, it's saying the maximum diameter is 1.7, so I'm going to make that a little bigger, maybe about 10 or 20 thousandths bigger, just so that I have, so I'm cutting something off when I go and machine that with the end mill. So I'm going to take this down to 1.72, negative 4.25, and then 1.72, negative 4.5, and that should be good. And actually, you know what? I changed my mind on that. I'm just going to turn this back straight. I'm just going to machine that whole thing. So let me redo this line. Just thinking about the process, I think it'd be better. I'd be better served if I did this. 2.35, negative 4.5. Okay. So that's good for our initial shape, and then I'll just use an end mill to cut that whole thing out of there, that whole, this whole profile. Rather than turning and roughing it in, I'll just machine the whole thing out. Or what else I could do is I could actually come down and turn it from the back side when I turn around, when I flip the part and pull it with the subspindle. Okay, so there is my profile, and that looks good. All right, so now I need to start drawing some of this stuff here. So I'm going to start with this ellipse that is on the front, and I got to be careful about the way this ellipse is oriented. So the way that this appears, the ellipse is oriented. It looks like it's the right face. So you can see here in this view, the ellipse is oriented vertically. So this actually isn't really a correct representation if we're saying this is the right-faced view. But we'll take it. We're going to copy what we have here. So I'm going to make my my length, my 2-inch diameter here. I'm going to make that in line with my profile. Okay, so let's go to planes and let's go to the right side equals, and I'm going to go to top. And you're going to pick top here because when you right click, you want to be, since we're on right side, you want to be seeing the right side from the top. Okay, so we're going to pick our ellipse, which is under shapes, ellipse, and we're going to go 0, 0, enter. And our first radius, I'm not sure which one is which, so I'm just going to type one in. Looks like 1.0. Actually, that's our diameter. 0.5, tab 1.0. Enter. Okay. All right, so that's clearly not the right direction, right? That's the opposite of the direction that I want, because here is my profile. I want that long 2-inch section to line up with that. So what I'm going to do is I'm going to flip those. So I'll make this one 1.0 and this 1.5. And I'll hit the check button, and that looks good. Okay. So now that we have our ellipse, what we're going to do is we're going to create these lines. Now this dimension is giving us, it appears to give us the length of that line, but I'm not really confident that's what it actually gives. I think that's what it is though. I'm going to create that line. I'm just going to be sure that it's right. So I'm going to draw a square and I'm going to draw this circle, and I'm just going to trim so that I can get my lines. So if you kind of don't understand what I'm saying, we'll see here, and it'll be pretty clear once I go through it. The Z level for this line is... All right, so I don't have a clear Z level here. So by appearance on this, and I'm going to go ahead and assume this since it doesn't have it clearly labeled, I'm going to assume it's centered on this here surface, which is 0.9 minus 1.5. Okay, so it's 0.75 here. So basically it's 3/8 from the edge of that surface to the center, plus 150 on top of that. So 3/8 plus 150, that's going to be what? It's going to be 475, 525. So it's going to be 525. So 0.525 to the center there. Okay, so that's where I'm going to draw my negative, or my lines negative in the Z level. All right, so we're going to make a rectangle, and we're going to make this at 0, 0, negative 0.525. Oh, anchor to center. And I'm going to make that 2 point by 2 point, enter. Check that, and then I'm just going to create my circle in the same place, 0, 0, negative 0.525, enter, and that is going to be a 3.35 diameter, 3.35, enter, whoops, MS, oh, 2.35. There we go. Okay, then I'm just going to trim these lines off, and I'll have my flats. So let's go to divide, trim these corners, and then I'll delete the circle. Delete that, and there are my flats in the correct Z location. All right, next I'm going to create my points for the holes. Let's take a look at the print again. So our holes aren't really dimensioned here, but we do have a dimension from what appears to be center of hole to the edge of this line, which is a really weird way to dimension it. Why you wouldn't dimension it from center is beyond me, but it's still a dimension that we can work with. So we know that well, we don't know yet. We'll have to measure. So what I'm going to do is measure from the end of this line to the center of my part. So I'm going to get back to my top view here, and let's measure drafting. Actually, I'm just do smart dimension from center to the end there, and I'm getting 617. Okay, so what I'm going to do is I'm going to take 0.617 and I'm going to subtract that dimension of 0.4113. And when I subtract that, it's going to give me the distance from center to center of hole. So center of part to center of hole in that axis. So when I do that, 0.617 minus 0.4113, I get 2057. Okay, so let me go ahead and delete that. Oops, delete that. And let's go ahead and create my points. So I'm going to go positive x, 0.2053, or sorry, 2057, 7, comma, this is positive 1 inch in the y, so I'm going to go 1.0, and my z is comma negative 0.525, enter. And there's my point. So I'm going to do my other point quick. That's going to be negative 0.2057, comma 1.0, comma negative 0.525. And there we go. So I have my 2 points. All right. Now rather than draw those points all around, I'm just going to rotate them. I could have just drawn one line and rotated as well, but I drew that square, so it was just as easy just to trim and do all the lines at once. So I'm going to transform, rotate this, and we're going to do 3 at 90 degrees. And I'm going to go ahead and hit check, and there we go. Okay. Now, we're going to come back, and we're going to do something a little different with these points. I'm just drawing those points right now and not circles for a reason, to show you something with one of the toolpaths later. So we'll revisit that, and we'll actually end up drawing circles in the end. Okay, so there we go. So we got all of that stuff done on the front face. Now we need to work on the back face. So we have kind of like a, I don't know, like a lobed cloverleaf type shape back here, a little plus sign. So we need to add that, and we also need to add these holes that we have. So the first thing I'm going to do is I'm going to start with the cloverleaf sign just to get that out of the way. No reason I'm starting with that. I can start with the holes. Doesn't make a difference. Bring that back up. Slide it over. All right, well, actually, let's look at this quick. So it looks like 1.7 is to the outer diameter here. And we know the radius of this is 0.25. So if I divide 1.7 by 2, what do I get there? Should be 0.535, should be 835, I believe. 1.7 divided by 2, sorry, 0.85, yeah. So 0.85 is from center to the edge. And if we subtract the radius of this, then that's going to give us center of circle. So 0.85 minus 0.25, that's going to give us 0.6. So I know that my radius is at 0.6, or the center of my circle is at 0.6. So it's going to be 0, comma 0.6. Actually, I do have a z value. So rather than type in a z value the whole time, I am going to set my z level for where I'm drawing. And I can do that by clicking in this box, and that's going to be at negative 4.5. Enter. All right, so now everything I draw will be drawn at that level. The only way I can get around that, and it won't draw at that level, is if I click on something that's already drawn, like if I snap it to a point here. Then it will draw at whatever level that point's on. So go ahead and pick this. I'm going to go 0, comma, 0.6, comma, enter. Okay, let's try that again. 0, comma, 0.6, comma, enter. Oh, because I put a comma. I'm an idiot. Let me try that again. 0, comma, 0.6, enter. There we go. If I put a comma after my y-axis, then it's expecting a z value, and it will just error out. So just a small mistake there on my part. 0.5. So there is our circle. Okay, so that looks good. I am going to draw a short little line coming off of that. And I'm going to trim it. And I'm going to rotate this here loop, this U around. So I'm going to select those, and I'm going to go to Transform, Rotate 3 times, check, looks good. And then I'm going to fillet this. And I believe if I check my print, it is a 1/4 inch radius in there. Okay, so let's go ahead and select our fillet, and we got a 1/4 inch radius already selected. Perfect, 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 and perfect. Oops, what the heck happened there? There we go. And check. Okay, so there is our shape, and you can see it's drawn at the negative 4.5. That's supposed to be. Okay, so that shape is done. Next, we're going to work on those holes. So we have these holes, they're 1/4 inch holes, and they are drawn at on a bolt circle radius of 0.85. Okay, so we have something for this. This will be really easy. First off, I'm going to change my Z level, and those holes are at 4.25. So I'm going to change that to 4.25. Actually, it's in the negative 4.25. Enter. And I'm going to go to my top plane again, and we're going to go to wireframe. We're going to go to bolt circle. We have a total of 0, 0 is going to be our base point. We are going to draw 4 holes. We are going to make that at a diameter of it's going to be 0.85 times 2, which is 1.7. And our start angle is going to be 45, so that's going to rotate this bolt pattern 45. So I have a hole here, 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 here in the corners. So 45. All right. I'm going to create arcs. I could just create points if I wanted to, but I'm just going to create arcs since it allows me to really easily. And they're going to be 0.25 diameter. And there are our holes. Hit check. And they're exactly at the right Z depth as well. So that is basically almost it. The only thing we have left to do is this spline that we have to create. So for that, it's just giving you the points. So if I look at this, it's just saying create points for spline from the top WCS. So it's important you switch to the top and then just type these points in. Really simple. So it's just giving you that. So let's go ahead and go to planes, top equals, and I'm just going to go to top, and I'm going to select my spline, and I'm going to start typing my points, which is negative 4.0, comma, 1.175, comma, 0. And then we're at negative 3.75, comma, 0, comma, negative 1.175. Next point is at negative 4.0, comma, negative 1.175, comma, 0. And next point is at negative 3.75, comma, 0, comma, negative 1.175. Enter. And, oh, I messed something up. Yeah, that's not quite right. Let's escape out of there. Let's undo that. Let's get undo. I must have typed in a dimension wrong there. All right, let's start again. Negative 4.0, comma, 1.175, comma, 0. Negative 3.75, comma, 0, comma, negative 1.175. Negative 4.0, comma, negative 1.175, comma 0, and negative 3.75, comma 0, comma, oh, there's probably where I went wrong, 1.175, enter. Okay, so there we go. That looks a little better. And then you're just going to click on your first point to end it, check, and check. And there is our our spline that goes around the part. All right, so our part is all drawn. So we are now ready to start machining this. All right, so I'm going to go to my top view. I'm going to go to my planes, work on my DZ plane, hit equals. All right. I have my default lathe open. Let's work on creating our stock. So let's create that on DZ and our stock in the spindle. All right, so what I am going to do here, I am going to hold this part. So really what I'm looking at is I'm going to look at this part and see how I'm going to machine it. My plan here is to hold on to this back side inch or maybe a little bit more. I'm probably put a bit of a margin on the back side here. But I'm going to pretend like this is a slug. So I'm slugging this out, maybe give myself like a 4 3/4 inch slug. Hold on to this section and then do all the work up to this point. And then grab it with the sub spindle and then do all this work on the back side. So that is my plan right now. The other option would be is if I had a spindle that could take maybe 2.5 or 2 3/8 bar, I could do all the way up to here and then cut it off, grab it with the sub spindle, then cut it off and finish the backside. So those are the two options. I'm going to go with the slug option because 2.35 is bigger than anything we have in the shop. And I also believe that your book has you do it this way as well, as if it was slugged, not cut off and picked off. So let's go ahead and move forward with that. Okay, so the OD, we're going to want this to be 2.35. Our length, let's make that 4.5. And I'm going to use my margins. And I'm going to put an extra 1/4 inch on my left margin, just for a little bit extra to hold on to. Then I'll face that off when I grab it. Right margin, I'm always going to put 0.01 on there and hit check. Oh, yeah, screwed up here. That's going to be 2.5. There we go. Once I saw it, that lined up with the outer edge, this thing ain't right. All right, so there is our stock. Now, I'm also I'm gonna actually use my jaws on this one just to give me a reference so that I can see if my tool's cutting into my jaws. So I'm gonna hit properties, and I'm gonna use my diameter, which is going to be 2.5, and my Z is going to be a negative 3. I'm gonna go a little more than 3.5. I'm gonna go like negative 3.6. Depending on what we end up with, we might change that. I'm not sure. So that we could adjust this potentially. Okay. So that looks pretty good. So we're holding our work. Again, I'm going to hold this piece of work just with the end here. This is slugged, and then we're going to machine it up to this point. All right. So let's go ahead and start turning this. We can face it and we can rough it out. Let's pick our turning face. And let's grab our, actually let's go to our, or the one I created. So we're going to go to lathe. Oh, you know what? I never created them in this one. So we're just going to use lathe inch, I guess. Because I don't think I created lathe steel tools in here, or lathe. Nope, that's at my, on my other computer. Okay, so let's go ahead and use our profile tool. And we're going to go 900 inches a minute. Actually, I'm going to make this 2,000 since we're cutting aluminum. Feed rate, we're going to feed at 0.01. And our face, our step over. It's fine. Everything there is fine. Oh, I'm sorry. I'm facing. I want to change this. 0.006 for facing. Sorry. Computer. Everything in here is fine. This is all set. So I'm going to hit check. Phases it. All right. Now let's rough. That's what I thought we were doing there a second ago. By mistake. So I'm only going to go to there. So obviously if I go any further, I'm going to hit my jaws, right? So I'm going to select that. And I'm going to pick this tool. The reason I'm facing with this is just because it's the only tool I'm not going to use. I'm not going to use my traditional 80-degree diamond because I can't use it to get into this groove. So I might as well just put one tool in rather than putting this in just to face. Okay, so I got this selected. Max spindle speed is 3,000. Spindle, we're going to use 2,000 for that. And our feed rate, 0.01. Rough pass, since we're using this less rigid tool, we're going to make this 50 thousandths. Maximum depth of cut, 0.02 for our minimum. And our Z, 0.005 is what we're going to use. Okay, everything there looks good. Off to the right. Let's check our plunge parameters. So we're plunging in both directions, and our lead in, lead out. I'm going to extend this maybe like 0.02, just a little bit more than the tool nose radius, and hit check. And stock recognition should be on. So use stock for outer boundary. Obviously, I don't have my default set up on this machine, so I'll have to do that at some point. Hit check. Okay, collision with the tool. So I knew this was going to happen, but I wanted to kind of show you so that you see what the issue is. So the problem here is my lead in. It's trying to lead in from 3 o'clock. It's trying to lead and basically go from center to 9 o'clock. So what we're going to do is we're going to go in and change that lead in. Oh, escape. Okay. So let's go and change that lead in. And it's because of this. So if I lead straight down, I should be okay. Regen that. There we go. So that looks a little bit better. All right, let's simulate that, see how it looks. Drag this over, hit play. So that looks pretty good to me. Can definitely live with that. Don't worry about this. We're going to turn all that off. Now, by the way, the reason I am choosing to end at this point here, rather than maybe in the middle of here or something, is because those points, I'm not going to have a match turn. So basically, I would have to make sure this was perfectly concentric for that to match up. Here, it's not going to be noticeable because all I need to do is turn straight back past that angle that I created. And that's also why I extended it a little bit so it goes past. So that corner will just be perfect. You won't see any kind of mismatch in concentricity. So I always try to use a change in direction if I'm going to match turn something. All right, so that looks good. The next thing I'm going to do is I'm going to mill this outer ellipse here. Okay, so to do that, we're just going to pick a face contour. And I'm just going to select a single. There we go. I'm going to reverse that because I want that to climb mill around there. Tool. Let's go get a tool from the library. We're going to use a 1/2 inch end mill for this. There it is. All right, and my feed rate is going to be, we'll feed this at about 20 inches a minute, spindle speed of 5,000, and make a plunge rate of 15 because we're not really going to plunge into the part. All right, compensation type, computer is fine. I'm actually going to put where on for this since I'm milling. Depth cuts, no, we can take all this at once. Lead in, lead out. We are definitely going to turn our lead ins on. Make it 10, 10, and contours all right. So everything there looks good. Multi-passes, we're definitely going to have to use multi-passes. So I'm going to start with 4 of them with a step over of 0.2, and we'll just see if I need to add more or maybe reduce it. We're going to have 1 finish pass with 0.01. Linking parameters, the depth is going to be negative 0.15. And we're going to keep everything incremental. Everything there looks good. So I'm going to hit check. Cutter compensation not successful. Okay. Oh, I'm off to the wrong side. That would be why. Let's give that another go. Okay, off there. Yeah, I didn't change. That's because I changed the direction of my, but I never changed the cutter compensation. There we go. That's a little better. So if I look at this from the right side, it's going to show me that diameter. Basically, that's a little bit lower than the diameter, but I could probably get rid of one of these passes, is my point. So I'm going to go ahead in there, and I'm going to change that and get rid of multi-pass. I'll make this down to 3. And regen. All right, so that looks good. So let's go to top, and let's simulate that. Let me reduce the speed. Run that again. I was kind of going a little fast there. So basically what I want to see is that when it starts, I don't want it taking too much. All right, so right there, you can see that's all it's taking. So that's perfect, actually. That's starting out perfect. All right, and then it's going to run a finish pass, and it's done. Okay, so that looks good. All right, so our ellipse is good. Next thing we're going to do is we're going to put these flats on here before we drill it, because we really can't drill it until after we put the flats on. I guess we could, but it wouldn't be smart. You'd want to drill into a flat rather than the side of a round surface. Makes it a little more difficult if you try and do that. Okay. So we have cross contours and we have C-axis contours. So the C-axis contour, if you hover over these, by the way, it tells you what they do. C-axis contour wraps around the geometry, which is what we're going to use for this. For what we're doing, we're going to use a cross contour. And I'm just going to select these. Check. Tool. Looks like the width is 3/8 of an inch, so I'm going to go in and select a 3/8 end mill. Now, if I was making this in a lathe, I may just use a 3/8 for everything. It actually would make sense so I can reduce the amount of tooling. So I probably would use 3/8 for everything if I was actually making this part. Feed rates, we're going to go about 20 inches a minute. Add a spindle speed of 5,000. And let's make our plunge rate at, let's make that 15 too, because we're not really going to plunge into anything. All right, our compensation is off because we're doing a slot, so that's correct. Depth cuts, we don't need to do it. It's aluminum. We're not cutting that deep. Lead in should be all, actually lead in, lead out should be on. Entry and exit should be off. We are going to adjust the start of this contour a little bit more than the radius of the cutter, so it starts and plunges off of the part and goes across. So I'm going to do this 55%, extend it, and I am going to extend the end just 5%, just so it goes a little bit past. And that looks pretty good. Multi-pass is fine. Linking parameters. We selected these. These are technically where the bottom of the slot is. So going to a depth of 0 is the correct place to go. Our top of stock actually should be basically where the highest point is that it's going to be cutting into. So I'm going to make that 0.2, and I'm going to make this 0.25. And our retract plane, I'm going to make that 0.3, and I'm just going to turn our clearance plane off. And hit check. And there are our slots. So let's go ahead and check those out. It's cutting it. Looks good. So I just want to make sure it's not going to plunge into material. I want to make sure it's clearing here. Yep, and that looks good. Didn't plunge down into it. So everything looks good there. I've got the slots in it. All right, next we are going to drill these holes. All right, so this is where we run into a little bit of a predicament. So if I select C-axis drill, it'll tell you that it's going to drill it perpendicular to the spindle axis. What that means is the tip of the drill is always going to point directly into the spindle axis. So you can't drill off center on a part. So if I had a round part, I can't drill off axis on it. So C-axis drill is not going to work for us because these are off center holes. What we have to use is our cross drill. Now, when you use a cross drill to do drilling with points, I have to turn my depth filter off. Drilling with points, if I hit enter, and I'm going to select my tool, and we're going to pick a spot drill. I'm going to pick a 1/2 inch spot drill. I think that's going to be too big. We might have to alter that. Feed rate of 8.0, spindle speed of 2000. Cut parameters, we're just going to drill, that's fine. Linking parameters, we're going to go a little bit deeper than half the diameter hole, which is a 0.25 hole. So we're going to go, the radius of that is obviously 0.125. So we're going to put a 5,000th chamfer. We're going to go negative 0.13. All right, now, top of stock's going to be 0 because the holes are at the top of stock. Now, I'm going to hit check. Now notice that the holes are directed in towards the center of the part. Right? That is not how we want them to be. We want them to be coming straight down. So, the reason it does this is because it has no reference geometry to see where the plane that it's level to is. So since I don't have any reference geometry, it's always going to drill to the center of the part. So to fix that, what you have to do is you have to put circles. You have to draw circles for this. So if I put a diameter of 0.25, lock that, and let me just make sure I'm clicking these in the right place. And if I draw some circles there, hit check. And let's go to my entities. I'm going to delete these points. And I'm going to reselect the circles this time. Whoops. Didn't want to do that. Delete. There we go. Enter. And let's regen that. Now you can see those are perpendicular to this D-axis here. So that is how you have to do it to get these things to drill the correct way. You have to use circles. Now, that being said, what I'm going to do, rather than just select more circles, I can also use my toolpath transform. And I can go over and select that toolpath. Rotate. No, I don't want to unselect it. Go to my rotate. It's going to probably ask me that again. No, it didn't. Good. 3 more instances, and my rotation plane is going to be around the right face. This face here. And hit check, check. And there we go. Now it rotated my part around the correct direction. And I'm going to go ahead and hit top. And there we go. So we're going to go ahead and simulate that real quick. Play. speed this up. And there we go. All right, so you can see there it did definitely notch our pieces out. So we're going to have to change the diameter of that tool and use a different tool. All right, so what I'm going to do is I'm going to go into that drill, and I'm actually just going to alter it. Make a drill diameter 0.3125, so 5/16 finish. Update assembly using that. Regen it. All right, and that should work. Let's just double check here. Yep, looks good. All right, so once we drill this, we'll see if it actually is putting a chamfer, which it very well should be. All right, let's see. So we're going to use our cross drill again, and we're going to select previous points and hit enter. Enter. Move this thing. Check. There we go. For some reason, it wouldn't take my enter. All right. So tool, and we're going to use a 1/4 inch drill here. 1/4 inch. Where are you at? I must have missed it. No, I didn't miss it. There it is. 1/4 inch drill. We're going to drill about 10.0 at spindle speed of maybe 1500. Cut parameters. We're just going to drill this. We don't need the peck. Our depth. Let's take a look at our print. So our depth, it's telling us, we don't really have a depth on here. But what it is telling us that this is 1 inch, and it's telling us that the start point is 2 inches. So it looks like these are about a 1/2 inch deep. And that is to the tip, not to the shoulder of the drill. So we're just going to put a total of a 1/2 inch in there, and we're going to assume that. In these tutorials, sometimes the prints aren't complete, and that's just because they go through it in the tutorial. So we're going to assume that's a 1/2 inch, depth a -0.5. Everything there looks good. That should be it. Hit check. And there we go. So it's drilled our 2 holes there. Now, what you may notice here is that we have to transform these around again. So I'm going to go up to my transform toolpath. I'm going to select that drill toolpath. Rotate. Everything there looks good. I believe the rotate should be the same. And yeah, so we're good there. Okay, and there we go. So select all these, and let's run that. And there we go. Looks like we have a nice little chamfer on there. They should all be chamfered. Yep. So everything looks good there. Okay, so that's pretty much it for this side. So now we're ready to do this stock transfer. So let's go ahead into top. And first off, before we do this, let's save it. Let's go to File, Save As, Lathe Assignments. And I'm going to go, I think this is tutorial 2. So I'm going to save that over top of it. Yes. Oh, okay. Looks like I already have that open somewhere else. Save as, Lathe Assignments. Let's make it. There we go. So now we're saved. So if anything happens, it crashes, we're good to go. Okay, so let's go to our stock setup and let's define our right spindle, because we're going to need to use that. Parameters, we're going to be holding on to 2.35, and I don't care about the Z value right now because we're going to set that in the We're going to set that in the stock flip. Let me just regen everything. Okay, so it's... So I do care about that a little bit. Stock. Let's make this like... Check. There we go. Now they're way over there. Now our tools don't run into them. All right, so we've got our jaws set up. Now we're going to do a stock transfer. We'll do a pick-off later. But for right now, we're going to do a stock transfer. So in this dialog box, I'm going to get rid of blank original geometry. I want to keep that original geometry. I don't want to make that disappear. It's going to copy this geometry. So I'm going to select all my geometry so that it copies it and flips it, basically mirrors it. And I'm going to hit end selection, so that's good. All right, so from back face... So where's our stock at in the Z, our original position? So we have to finagle these numbers. There's a couple of things in here that I don't even fully understand why it works the way it works. But you can finagle them in. So it's pretty easy because it's going to simulate it for you. So where is this position? We're going to say that position is essentially at like 2.6. So we're going to say it's about 2.6. It's negative, or actually, check that. It's going to be negative 0.9. Transferred position, that's going to be negative 0.9. So what I'm saying is the transferred position, I want it to grab on to basically right up to that little corner right there. So I wanted to grab it. So I wanted to grab it negative 0.9. We're going to have to adjust that number because I believe this is off by about 225 thousandths. Main spindle, you don't need to change any of that. Main spindle is basically always where it's at. We don't have a sliding headstock or anything, so that's just going to stay what it is. Sub-spindle position, so this is the original position. That's going to be at 30. That's good. It's already set. Our D value is already set. And our pick-off position, this one also is going to be 2.35. And our Z value for this should be, yes, negative 1.125. So I'm going to hit you. And it used all these numbers to calculate that. So we may have to come back and adjust these, but let's take a look and see what happens here. Okay. So you can see there, this is where it's putting it. So we need to make sure that we change that. Yes, because negative 0.9 is my problem there. We want to go to... Basically, we'd want to go to 30 minus 0.9, so we'd be at 29.1. Check. And let's reach in that. All right, so that should put it over here. There we go. Now, that grip that I told you about, that's a little goofy, so we need to look at that. And it's going to be negative 0.9. Let's give that a go and see where that ends up. All right, so there we are. So we're right where we should be. Let's go ahead and face this thing. And, all right, so let's go up to our turning. Let's go to face. And, of course, I'm going to select a left-handed tool now. I'm going to run this at the same speeds and feeds. So I'm going to run this at 2,000, 3,000 max spindle speed, and our feed rate 0.006 for a face. Okay, so we want to rough this. We're going to take off 50 thousandths for a rough. And we probably get away with 100, but we'll just be a little conservative. We're going to be off to the right. That is correct. Stock to leave. No, I need to select my points for this. So I'm going to select this one, and so we go a little below center and out in front of the part. And now I'm probably going to run into a problem here. I'm going to hit check. Okay. Now it's saying, tool collides you with stock on the right spindle. This tool is programmed to cut in the left spindle, change axis combination, and generate the tool path. All right, so when we're cutting in the spindle, we have to change our axis combinations. Yes, I want to keep this operation. I'm going to go in and edit this. So this is important to remember. Tool paths, and we're going to go here to our axis combinations. So I'm going to click this button. And now I'm going to be in the upper right. So I'm going to pick right and upper because my turret is in the upper half of the lathe. And it's going to be, if you're kind of standing in the view of the turret, you're on the right side of the part. So I'm going to hit check and come in here. All this looks good still, and regenerate that. So let's see. Hopefully that does what we want. Yep, there we go. All right, so we've now faced it. Now we can turn this thing. I believe I didn't create a line here, so I'm just going to mill all that away. I think I came to that conclusion. I'm going to mill all that away. So what we're going to do here is we're going to go to a rough, and I am going to select a single. Select that. Check. And we're going to use that same tool. Make sure our axis combination is correct, because it will alarm out on you again if it's not correct. We're going to go 2,000 and 3,000 max spindle speed. Depth of cut, we can actually take 100 now because we're using a different tool. Minimum's good. 5,000 good. Computer's on. We don't need any plunging, I don't believe. We turn that off. Our lead in is perfect. And our lead out, we're just going to extend that a little bit. Let's extend it 0.1. And that looks good as well. I'm going to hit check. Disable stock recognition. We would definitely want to use stock recognition. We use remaining stock on this one since we've already started machining. And you can see there, it just takes it in one pass. So it was obviously less than what we needed to take. So now we're just going to do a finish. And I'm going to do the same thing. I'm just going to select last, check. Same tool. Axis combination needs a change. Spindle speed is going to be 2,000 at 3,000 RPM. Everything looks good. It's all zeroed. And let's see what that does. Okay. The only thing I need to do is extend that contour. Did forget to do that. So used to having my default set up that I forget to do it. Check, check. The important part is that I'm recognizing it when I do it. So I recognized right away that that was an issue. All right, so that looks good. Let's go ahead and run this. Let's simulate this and see what we get. Okay, so we got our stock starting in there. We know that simulation looks good, so let's run through this. Drills the holes. And it's going to come over here in a second. There we go. So we faced it. And now we're ready to finish up on this side. Okay, the next thing I'm going to do is I'm just going to mill this we'll call it spline around the outside here. So to do that, I am going to use my C-axis contour. So I'm going to go ahead and select that. And select my spline. Doesn't matter which direction you go because it's a slot. So either way, it's going to be climb and conventional milling at the same time. All right, I think we need a 1/4 inch end mill for this. So I'm going to go ahead in and look for my filter. None, end mill, flat, 1/4 inch. Okay, we're going to run this at about 20 inches a minute, 5,000 RPM. Could probably run it faster. Just being conservative here. Computer, we're going to turn this off because we are doing a slot. It is a 3D contour. Depth cuts, don't need them. Don't want any lead-ins here. Multi-passes, nope. All we need is our depth, which is going to be negative 0.0625. And I got that by actually going through the tutorial because it doesn't tell you on the print what the depth is. So you have to look in the pages for that one. Everything here looks good. These are all incremental above the geometry, which should be fine for clearance. The only thing I need to change here is this. I need to add my rotary diameter, which is 2.35, and hit check. And it's going to calculate this. This is kind of a complex path, so it takes a little bit to calculate it. If you get these little breaks, don't worry. They're not actually breaking. It is milling around there. So don't worry about it kind of stepping out. We'll see it in the simulation. It looks fine. In fact, actually, let's simulate that before we go on. There you go. So we have our slot the whole way around, and that looks good. Alrighty. Next, we're going to go ahead and mill this face. So we're going to do a face contour. And I'm going to select chain. I'm going to chain this. And if I want to climb mill, I'm going to need to reverse that. And I'm also going to change the start point and make it up here at this highest diameter. And then we're going to come in and we're going to mill that. So for this one, looks like we have a 1/4 inch. I'm going to use a 3/8 end mill for this. We're going to mill this at 25 inches a minute. Spindle speed of 5,000. Plunge rate, we're going to plunge at 15 inches a minute because we're not going to plunge into the part. Cut parameters. We have wear on. We are off to the left. That is correct. Everything there looks good. Depth cuts, no. Lead in, lead out, absolutely. Move this over. And breakthrough, no. Multi-passes, yes. So we might take a few multi-passes here. I'm going to make this 0.15 since I'm using a smaller end mill. And I'm going to make this 5 multi-passes. We'll see if we need that many. Again, I can always reduce it. I could just do the math, but it's quicker just to run it and see if I need to add or subtract multi-passes. The depth looks like this is a 1/4 inch deep, so we're going to go negative 0.25. And that should be it. Oh, cutter compensation. I must have had it off to the wrong side after all. Okay. I thought we were off to the left, but I must have been mistaken. Wonder if we're going the wrong way for climb milling. I think we are, because we should be going around that way. That looks right. Let's take a look what we got here. Also, I put a positive in there, obviously, instead of a negative. You can see my linking parameters the wrong place. Oh, sorry, it is going to be a positive because it's positive in my z-axis. So that's something to keep in mind here, right? My z-axis has changed now, so now I'm working on the positive. So remember that. When you actually work in the Haas lathe, it will automatically, there's a code that will switch the axes around for you. So go to the right side. I just want to see where this is relative to the outside part. So this spline roughly represents the outside diameter. And you can see it's really not cutting much. It's definitely not cutting with this one. So I'm going to take one of those away. I'm just going to start with 4 multi-passes. And we'll simulate that and see roughly what that gives us. 4, check. All right, so this is a center line motion here, so it probably is digging in there a little bit. But we'll see. If it doesn't, I'll just remove another one. No big deal. Let's move this around so I can see it. And let's simulate that. Whoa, we have a problem, don't we? Okay, so what we have to do, and this is why my cutter comp was bad. So what we have to do is we have to flip that around. So we didn't pick an axis for that, an axis selection. So let's go to, actually I think it's under our tool, or where is it? Axis control, here we are. So we want right upper, check. We're also going to want to change our cut parameters. It's going to be off to the left. And we're also going to need to change our depth, which is going to be a negative 0.25. Check. And let's regen that again. All right, so that probably appears a little better there. Let's go ahead and simulate that. So sometimes you just forget simple things. I was wondering why that compensation was different. Didn't seem to make sense, but it immediately made sense once I saw that. All right, so that looks good. Taking our 10,000s finish pass, and there is our profile on the end. All right, so we're basically two operations away from finishing here. So we're going to do some face drilling, and I'm just going to select these holes. Turn this off so it doesn't give me trouble. There's our holes. Hit check. Tool. Let's use our 1/2 inch spot drill, which actually is a 5/16 now because we changed it. 8.0 and a spindle speed of 2000. Drill, and these are 1/4 inch, I believe. They are. So we're going to go 0.13 and put a 5/1000 chamfer around the outside. Everything here looks good. The only thing I need to change is my axis where's my axis combination at? Oh, it's down here. It's right. Upper right, check. And you can see right there I have my holes being drilled. And it looks like, if I'm not mistaken, looks like I put a bad number in. Looks like I put a positive in for my linking parameters. I sure did. Negative, check. And let's regen that. All right, that looks a little better. Let's go ahead and do another face drill. And I'm just going to select my last holes. Check. Tool. Use that 1/4 inch drill again. Now, if I was actually making this in the lathe, and I wanted to drill these holes and these holes, I would have to make them two separate tools because I would have to have an axial tool and a radial tool. So this would be drilled with a radial tool, this would be drilled with an axial tool. So the drills would be fixed in different directions, different vectors. So they'd have to be two different tools. For the simulation, I'm just going to pick the same tool. No big deal for this exercise. But if I was actually making this, I would have to make two different tool numbers for this. 8.0, 1500, and we go with our cut parameters. That looks good. Linking parameters. What is our depth? I don't think it gives us a depth for these. It certainly does not. So that's something I'd have to go into the book for. I'm just going to go ahead and say they're a 1/2 inch deep. Just because I don't feel like going all through the book while I'm filming this video. Really, the depth is irrelevant. The important part is that you know how to drill the tools and do the tool path. So we're going to go to axis control, upper right. It's automatically assuming that. That's good. Kind of learned, I guess, what we were doing. And let's go ahead and run this. Oh, you know what? We might have a problem there. Probably have to change our clearance plane. No, I guess we didn't. Oof, yeah, it's right at the edge. So I would change that clearance plane. Because you can see the tip is right at the same spot, so it's a 1/4 inch. Yeah, so I would change that. But we have our chamfered holes, and that is our finished part. So the part is complete. We have all the features that it called for on it. So one thing I will do before I go is I'm going to go in there just for thoroughness, that linking parameter, and I'm going to make that retract 0.3, 0.3, check, and I'm also going to do it for this one as well. 0.3, 0.3, check. And I'm just going to regenerate that. Okay, I'm going to save this. I just had a scare there when it kind of went blank. I was afraid it was going to crash. Should have saved it a couple more times during this. And I'm just going to simulate that real quick again. Finishes, drills my holes, and you can see now I have a little bit of clearance there. So I don't have to worry about that hitting. Now, it didn't hit before anyway, because it was the same level, but you know, I still want there to be a little clearance when it's turning around. So that is it. That is our finished part, all done. As always, if you have any questions, you can ask them during class, or of course you can see me during my office hours.